How is it going, ladies and gentlemen? This is the Wolf around, and it's great to see you here. In this video, I'll show you how to import image generation models into the ComfyUI container we created in the previous videos. I've explained everything in easy and concise steps. Subscribe to the channel, join the pack, you are always welcome here. Without further ado, let's get started. First, let's list existing containers with this command. Now let's run the container we created for ComfyUI. Next, navigate to the ComfyUI folder. Run the ls command to see existing files and folders. Navigate to the models folder. Then navigate to the checkpoints folder. We'll import image generation models here. By the way, the checkpoint means the base model itself that generates images. Whenever you hear the term for checkpoint, it means the base image generation model. First, we need to download models. One of the best resources for this is CivitAI. Here's the CivitAI website. I'll click the Models tab and narrow the filters to the checkpoints and SD1.5. SD1.5 is an image generation model, so it's a checkpoint. It's an older version of Stable Diffusion models, but still popular. It also has a relatively small file size. I'll explain why file size matters in a moment. Now let's pick a few SD1.5 models. The model called CyberRealistic looks nice. Let's open it in a new tab and pick one more model. CyberRealistic seems trained for realistic images, and the other one looks trained for landscape illustrations. This doesn't mean they can't generate other type of images. It just means they are primarily trained for these purposes. Now let's check the files section on the page. As you can see, the creator shared two versions of this model. FP16, lower precision, smaller file size. FP32, higher precision, larger file size. The file size is important because the model must be fully loaded into your GPU's memory. Image generation models require a GPU runtime. If the model can't fully fit into your GPU's memory, the generation will fall back to CPU runtime and it will be much slower. So how do you know if you have enough GPU memory? It's simple. Your GPU memory should be at least 2 GB more than the model's file size. For example, if the model is 4 GB, your GPU should have at least 6 GB of VRAM. This is because your operating system also uses GPU to keep your screen and Windows running. Let's download the 2 GB version of this model. In my opinion, there isn't a huge quality difference between FP16 and FP32 for most use cases. I'll save the first model to the downloads folder. And the second one to the My G drive. The download will take some time, so I'll skip ahead to when it's complete. Download complete. Let's import the models into our ComfyUI container. First, I'll import this CyberRealistic model. I'll right-click on it, open the Properties window, and get its file path. Now I'll use this path with this command. In Linux paths, you must use forward slashes instead of backslashes. Also, since the download folder is under my C drive, replace the C with mntc at the start of the path. That completes the first part of the command. The second part is the destination folder. Press enter, and the first model will be imported. Now let's import the second model. It's directly on my G drive. So we'll just type mntg at the beginning of its path, and again paste the destination folder. Now let's start the container and run ComfyUI inside it. I already showed these steps in the first video. We've successfully opened ComfyUI in the browser. Click Workflows and Browse Templates. Open the image generation template. Next, load the checkpoints we imported using this node. After tweaking some options in the KSampler node, let's generate a few images. We've generated a bunch of images, but how do we access them? There are two methods. First one, download each image manually. Second one, export the entire output folder. To export it, apply these steps. Stop ComfyUI with Ctrl-Z. Exit the container and run this command. I'll export mine to G drive. I'm a software engineer specializing in AI inference. Please like and subscribe, and I'll see you in the next one.